Okay, so now we look at question 8. Question 8, this is an exponential question, application-based question. So if we look at this question here, we are given the equation M of the mass of a radioactive substance given by this expression here. Okay, M naught times e power negative kt, whereby k is a positive constant. And it is given that the original mass of the substance is equal to 80 grams. So what does that mean is that original mass meaning when T is equal to 0, we know that M is equal to 80. So let's sub this into our equation. We know that 80 is equal to M naught e power negative k times 0, which is equal to 0. Therefore, e power 0 is equal to 1. Therefore, m naught is equal to 80. Okay, very simply, we have shown part 1. Okay, then moving on to part 2, find the value of k using the information given the question. After 20 hours, meaning that when t is equal to 20, then the m becomes 50 grams. So therefore, what this means is that when t is equal to 20, m is equal to 50. Okay, so therefore, if we sub this into the equation, we have 50 equals to 80. I know that m naught is 80 from part 1. Okay, e power negative k times 20. Okay, then from there, simply solving an exponential equation. Okay, e negative 20k is equal to 50 over 80. So therefore, to find an unknown power, I simply can take ln on both sides. So if I take ln on both sides, my left hand side ln e will become 1. This will become negative 20k equals to ln 50 over 80 can be simplified to 5 over 8. And therefore, k is simply equals to ln 5 over ln 5 over 8, the whole thing divided by negative 20. Okay, and therefore if I work this out into your calculator, you should get 0.0235 3SF. Okay, and this is the solution to part 2. Okay, then the next part, find the time needed, correct to the nearest hour, for the substance to decay to a quarter of its original mass. So that means the original mass is 80. A quarter of the original mass is 1 quarter times 80, which is 20. So therefore, they are saying, find T when m is now equals to 20. Okay, so if I sub this into the equation, 20 equals to 80 e power negative k. We know that k is ln 5 over 8 over negative 20. Then this whole thing times t. Okay, so therefore very simply over here, we know that t is simply solving an exponential equation. Okay, ln 5 over 8, the whole thing divided by 20, the whole thing times t equals to 1 over 4. Okay, simply divide both sides by 80, 20 divided by 80. Okay, therefore if I take ln on both sides, I have ln 5 over 8, the whole thing divided by 20 times t equals to ln 1 over 4. Therefore, t is simply ln 1 over 4 divided by ln 5 over 8 over 20. Okay, then from here we can simply get, if I round off my answer, t is number of hours, I will get to the nearest, correct to the nearest hour. Okay, I will simply get 59 hours. Okay, this is correct to the nearest hour. Okay, and this is the solution to part 3. And the last part, state the amount of substance left as t becomes very large. So if I look at the equation given, we know that m, the mass of substance, okay, the Tm is the mass of substance, is equal to 80 e power negative kt, which is the k found in part 2. Okay, so if I rewrite this equation, I can see this as 80 over e power kt. Okay, so if I analyze this equation here, as t becomes very large, as t becomes very large, okay, we know that this is an exponential function. As t becomes very large here, this entire e power kt will become very, very large. E power kt will become very large. Okay, and as a result, since this is a fraction, if the denominator of the fraction becomes very, very big, eventually, since the numerator 80 is a constant, this fraction will eventually tend towards 0. Okay, therefore 80 over e power kt will tend towards 0. So therefore, the mass, the amount of substance will tend to 0. Okay, and this is the solution to part 4. Okay, so therefore, let's look at question 9 now. Question 9, show that the roots of the equation are real for all values of a. So if I analyze this equation here, I can rewrite this because in any quadratic equation can be rewritten to its general form, which is ax squared plus bx plus c. So this can be rewritten as x squared plus 1 minus a the whole thing times x minus a equals to 0. Okay, so from here, we know that for a roots of an equation to be real, it means that the discriminant must be greater than or equals to 0. So let's find the discriminant, and therefore we have to show that the discriminant is always greater than or equals to 0. So discriminant is simply is equal to b squared minus 4ac, and therefore in this case it's 1 minus a the whole thing square minus 4 times 1 times negative a. Okay, then if I simplify this, I expand and simplify, I have 1 minus 2a plus a square plus 4a. I will get a square plus 2a plus 1. And if you notice, this is actually this can be rewritten as a plus 1 square. Okay, and therefore I know that any square number is always greater than or equals to 0. So therefore, since a plus 1 square is greater than or equals to 0, therefore roots of the equation are real. Okay. Please note for this question, if you at the start say that this is really greater than 0, this is wrong. Because the question wants you to show that the roots of the equation are real. If you start by saying that it is already greater than or equals to 0, you are not showing anything and you're not answering the question. Okay, so stating this fact here is wrong. You have to find a discriminant first, show that in this final expression for discriminant, it can be greater than or equals to 0 in order to answer the question. Okay, so remember, please take note of this point. Okay, let's look at 9b now. Find the range of values for this quadratic inequality. So for this quadratic inequality, I can see that I have this case whereby kx squared plus 6x plus k minus 8 is less than 0. So in order for this is a curve. For this curve to be less than below the axis, the x-axis for example, okay, we know that the discriminant here, okay, discriminant of this thing here, discriminant of this quadratic function here, discriminant must be less than 0. Okay, in order for this curve to be below the x-axis. This is what this is saying. Okay, so therefore, if I analyze your discriminant, it's simply 6 squared minus 4k times k minus 8 is less than 0. I'll get 36 minus away 4k square plus 32k less than 0. So therefore, if I divide the whole thing by negative 4, or yeah, divide the whole thing by negative 4, I'll get k square minus away 8k minus 9, and the inequality sign will flip to become this. Okay, and therefore, if I solve this, I draw the simple curve. This is a, based on this is a smiley face graph. Oh, but we should factorize first. If I factorize this, I'll get k minus 9 times k plus 1 more than 0. Okay, so therefore, if I draw this sketch, I know that the intersection points are negative 1 and 9, and I want the part of the graph that is above the x-axis, which is here and here. Okay, so therefore, in this case over here, therefore, I know that k must be less than negative 1 or k must be more than 9. Okay, and one more point to note, okay, in case you don't understand, right, this is actually a smiley face. This is a quadratic graph. Okay, quadratic graph, and this is your x-axis. Okay, so let's say this question wants this quadratic function over here to be below the x-axis, and the only possible case for this to happen is when, if this is your x-axis, okay, the graph must be a set face graph. Okay, graph must be a set face. Okay, and the condition for a set face graph is that the coefficient of x squared must be negative. So therefore, this is the implication for this is that k must be less than 0. Okay, so therefore we know that since k must be less than 0, therefore the answer is only k must be strictly less than negative 1. We cannot take this solution because k must be less than 0. Okay, and that is the solution to question 9 part B. Okay. Okay, so let's look at the next question, question 10. It is known that the variables x and y are related by this equation. On the grid below, plot this graph. Okay, so very simply, I will not. Okay, let me just quickly do the plotting. I think in order to plot the graph of log y against x, you must always have a table of values. So let me just quickly write out the table of values over here. Okay, table of values for log y, okay, is simply, if you just press into your calculator, you should get 0.301, 1.079, 1.875, 2.667, and 3.459. Okay, so if you were to sketch this onto your graph, okay, I think your graph should look something like this. Okay, okay, so if you sketch this onto your graph, I see it should be about 5, 3, 4, 5. Okay, 10, 0. Okay, 301. Then after that 1.079. So okay, here would be, okay, your point should all look something like this. Okay, so if I were to sketch this onto your graph, okay, here might look a bit inaccurate on my iPad, so I assume that you can plot accurate points. Okay, so if you plot this accurately onto your graph paper, you should get these values. Okay, so 30 would be here. Okay, 40 would be, okay, and 50 would be, yeah. Okay, so therefore your graph should look something like this. So therefore from there we can now label your graph as well. This case over here, once I've drawn this, I can actually form the straight line equation based on the equation provided. Okay, so over here we see that the original equation is y equals to 10 power negative a b power x. So if I want to turn this into a straight line graph, I simply need to take log. Okay, log y is equal to log 10 power negative a and b power x. Okay, and then we can split by product law. This is equal to log 10 negative a plus log b power x. Okay, therefore we know that log 10 is simply equals to 1, and by power law we can bring negative a down. So this is simply log b times x minus a. Okay, so therefore this tells us that the gradient, okay, therefore gradient equals to log b. Okay, and this log b can be calculated using the gradient of your graph. So based on the projected ideal answer, your gradient should be 0.08. Okay, and then therefore b will be equals to 10 power 0.08. Okay, but this one here you must show workings. Show workings. Okay, I'm not showing over here because I cannot get the accurate points, but you should be showing the workings of y2 minus y1 over x2 minus x1. Okay, then so therefore from here 0.08, okay, your b should be about 1.203 SF. Okay, and we know that this based on your y equals to mx plus c, this negative a is a y-intercept, so therefore okay, the intercept, the log y-intercept is simply negative a equals to negative 0.5, which tells you that a is equal to 0.5. Okay, and I found the values of a and b. Okay, and for the next part, find the value of y when x goes to 19. You can trace on your graph. When x is equal to 19, okay, you can check that when x is equal to 19 over here, x goes to 19, you can trace on your graph to check when x is equal to 19, your log y is equal to 1. Okay, so therefore over here, from graph, okay, from the graph, okay, when x is equal to 19, log y is equal to 1. Therefore, turn from logarithmic form to exponential form, y is simply 10 power 1, which is equal to 10. Okay, and this is the solution to part 3. Okay, let's look at the next question now. Okay, question 11. Given this equation, find the value of b. So in this case over here, I know that I see that b is in the power of 10. So as what we have learned before, in order to bring out unknown powers, we always use logarithm. So in this case over here, what I'll do is that I'll add this to both sides first. So therefore, 3 power x is equal to 10 power x log b. Okay, then from here, I'll take log on both sides. Log 3 power x is equal to log 10 power x log b. And we know that, therefore, I can bring down by power law. Okay, x log 3 is equal to x log b, and know that log 10 is equal to 1. So therefore, by comparison, we can see that in this case over here, and x is not equal to 0, so we can cancel that out. So therefore, log 3 is equal to log b. Therefore, by comparison, b equals to 3. Okay, and this is the solution to 11 part A. Okay, let's look at 11 part B now. Solve this logarithmic equation. I see two log terms of different base. So a natural instinct would be simply to convert them both to the same base. So I have base 5 and base 25. Logically, it's easier to convert something to base 5. So in this case over here, let's simplify. Log base 5, 25 over x plus 2. Okay. Plus, before we do the log conversion, we can make this to log 25x power 4 first, equals to 2. Okay, then from there, next step, I can now do the change of base. Log base 5, 25 over x plus 2 plus log base 5x power 4 over log base 525 equals to 2. Okay, therefore we continue simplifying from here. I have log base 525 over x plus 2, okay, plus log base 5x power 4. We know that log base 525 is equal to 2, equals to 2. Okay, my next step is simply to, what I can do is to simply get rid of this half over here. Okay, I can, by power law, I can bring this 4 down. So 4 times half will be simply 2. So therefore, log 525 over x plus 2 plus 2 log base 5x equals to 2. Okay, from here to here, I simply bring the 4 down. It will be 4 over 2, which is 2. Then after that, I can continue simplifying from here. I check, I can now combine them, okay, but in order to use my power law, I need to shift this back up first. Log base 525 over x plus 2, okay, is plus log base 5x squared equals to 2. Now by product law, I can combine them together. Log base 525x squared over x plus 2 is equal to 2. Okay, so therefore if I convert this to exponential form, 25x squared over x plus 2 is equal to 5 power 2. Okay, so by further simplification, since 5 squared is 25, I'll get 25x squared equals to 25x plus 50. Okay, I can simplify this very easily. Divide the whole equation by 25. X squared minus x minus 2 equals to 0. Okay, then simply solving a quadratic equation by factorization. X minus 2 times x plus 1 equals to 0. Therefore, x equals to 2 or x equals to negative 1. Then I check back first. We know that x is a number in this log function, and this number here cannot be negative. So therefore, I will have to reject, whereby x equals to negative 1. Okay, and therefore I have solved the question for question 11b. Okay, moving on to question 12. Question 12, it is given that sine A and cosine B is these values whereby A and B are in the same quadrant. So let's find the quadrant first. Sine A, this is a positive value. We know positive value based on my ASTC. Okay, my 4 quadrants, ASTC. When sine A is positive, it is only first or second quadrant. Let's write this down, first or second quad. Okay. Whereas for cosine B to be negative, it is only in the second or third quadrant. Okay, second or third quadrant. So therefore, if A and B lies in the same quadrant, therefore we can conclude that, therefore they lie in the second quadrant. Okay, so now with this useful information, I can now draw the quadrants. Okay, so let's draw a simple diagram. Angle lies in second quadrant. Okay, let's say this is A, okay, and this is alpha. Okay, I know that based on this thing over here, sine is opposite 3, 4. Okay, so 3, 4, this means that this part here by Pythagoras theorem, it is 4 square minus 3 square, which is 16 minus 9. Okay, which will be square root 7. Okay. Okay, this is for angle A. Let me make this clearer. Okay, this is for angle A. So therefore, I can conclude that for sine A, okay, opposite over hypotenuse, cosine A equals to adjacent over hypotenuse, root 7 over 4, and tangent A is equal to 3 over root 7. I can now do the same thing for angle B. angle B is also lies in the second quadrant. So if I were to sketch this out, cosine B, okay, negative 2 over 3, I can call this beta lah, okay? This is angle B. So cosine is 2, negative 2 and 3. Okay, so therefore by Pythagoras theorem, this length over here is 3 square root 3 square minus away negative 2 the whole thing square. So this will be 9 minus 4, which will be root 5. Okay, this is root 5. So therefore, sine B is equal to root 5 over 3. Oh, yeah, I almost forgot the signs. Okay, so let me write it out first. Cosine B equals to negative 2 over 3, and then tangent B is equal to opposite over adjacent, which is root 5 over negative 2. Okay, so over here, remember second quadrant, therefore these values are cosine and tangent are negative values in the second quadrant. Okay, alright, so from here now we can now solve the question very easily. We know that cosine 90 minus A is simply equals to sine A, okay, and sine A is simply equals to 3 over 4. This is for part 1. Part 2, tangent negative B is equal to negative tangent B, okay, and therefore this is equal to negative root 5 over 2, okay, which will give me root 5 over 2. And the last one, cosine A minus B, this is your addition formula. You can rewrite this to become cosine A cosine B plus sine A sine B. Okay, and I just need to sub in my values. Cosine A cosine B is simply negative root 7 over 4. Cosine B is negative 2 over 3. Then plus sine A, which is 3 over 4. Sine B is root 5 over 3. Okay, simplify everything, you should get 2 root 7 plus 3 root 5 over 12. Root 5 over 12. Okay, this is for part 3. Okay, and for the last one, half angle. Take note, half angle is obtained from your double angle formula. We know that cosine 2A is equal to 2 cosine square A minus 1. So if I turn this into half angle, if I let A be B over 2, this will become cosine 2 times B over 2 equals to 2 cosine square B over 2 minus 1. Okay, so therefore cosine B is equal to 2 cosine square B over 2 minus 1. So therefore 2 cosine square B over 2, okay, 2 cosine square B over 2 is equal to cosine B plus 1. Okay, therefore cosine square B over 2, okay, is equal to half times cosine B plus 1. Okay, so therefore I know that from here, okay, cosine square B over 2 is simply half times cosine B. Cosine B is negative 2 over 3 plus 1. Okay, so if you use our calculator to work this out, negative 2 over 3 plus 1, I'll get 1 over 6. Okay, cosine square B over 2 is 1 over 6. So therefore, cosine B over 2 is simply equals to square root, the positive square root, okay, because we know that if B is in the second quadrant, half of B will be in the first quadrant, and all trigo ratios are positive in the first quadrant. So therefore, I only consider the positive root. This will be 1 over root 6. Okay, and therefore you rationalize this. Remember, AMF cannot leave denominators with surds. This will become times root 6 over root 6. I'll get root 6 over 6. Okay, and this is the solution to part 4. Okay. Okay, now let's look at question 13. Question 13, this is a diagram made up of two right-angled triangles. So let's look at the question. Explain why AE, which is this length over here, equals to 7 sine theta plus 4 cosine theta. Okay, so by observation, you can see that BE in this right-angled triangle, we know that this is right angle as well. Okay, BE is equal to 7 sine theta, and AB is equal to this length here. Let me label. This length here is 7 sine theta. Okay, and this length over here is 4 cosine theta. Okay, if you find it hard to visualize, you can write out your trigo ratio first. Let's say in this case over here, cosine theta equals to AB over hypotenuse, which is 4, which is how I obtain this length. AB equals to 4 cosine theta. Okay, you can do the same thing for the other triangle. So in this case over here, AB is 4 cosine theta. And therefore, since AE is equal to BE plus AB, this is equal to 7 sine theta plus 4 cosine theta. Okay, this is for part 1. Part 2, express AE in this form. Okay, so over here, I'll let this 7 sine theta plus 4 cosine theta be equals to R sine theta plus alpha. By addition formula, this can turn into R sine theta cosine alpha plus R sine alpha cosine theta. Okay. Then from here, simply we can form the equations. Please note that all these workings are needed to score the full marks. Okay, so let's start by comparing the first term, 7 sine theta and R sine theta cosine alpha. By comparison, we can see that 7 equals to R sine alpha. I can call this equation 1. Next one, 4 cosine theta compared to this term over here. Okay, I can see that 4 is equal to R sine alpha. Sorry, I made the wrong comparison. This one is 7 should be equal to R cosine alpha for equation 1. R cosine alpha. Okay, then from here, 4 cosine theta compared to this. Cosine theta can ignore. This will become 4 equals to R sine alpha. Equation 2. So therefore, in order to obtain tangent, to get rid of the R, we take equation 2 divided by equation 1, sine over cosine. Therefore, tangent alpha equals to 4 over 7. Okay, alpha is simply tangent inverse 4 over 7. Okay, which will give me 29.7449 degrees. Okay, then from here, I can now find my R. We know that R is simply the square root of the square of these numbers. So R is simply equals to 7 square plus 4 square. Okay, which will give me square root 65. Okay, so therefore, final answer to this question. Therefore, 7 sine theta plus 4 cosine theta can be rewritten as square root 65 sine theta plus, and your angle alpha here, remember to round off to 1 dp. This will be plus 29.7 degrees. Okay, and this is the solution to part 2. Okay, and the last one, next part, hence state the maximum value of AE. We recall your sine graph. To find maximum value is simply the amplitude of the graph. So therefore, max value is equal to square root 65. Okay, and this happens if you recall your sine graph, the corresponding value of theta. In your sine graph, you know that in your sine graph, your shape looks like this. Okay, okay, and this is your x-axis. So therefore, your sine graph, the maximum value occurs at 90 degrees. Okay, so therefore, we know that it occurs when this corresponding value of theta occurs when this this angle here, theta plus 29.7 degrees, 29.7 degrees is equal to 90 degree, and therefore theta will be equals to 90 minus 29.7, which will give me 60.3 degrees and 1 dp. Okay. To be more accurate, I should use the longer version, which is 7449. Okay, to get a more accurate answer. Okay, and this is the solution to part 3. And the last part, let's look at question 14 now. In the diagram below, this is a quadrilateral, okay, whereby I have the points B and D, and as well as point E, and the equation of line BC, okay, and AC is a perpendicular bisector of BD, and AE is a point such that is perpendicular to the x-axis. Show that the y-coordinate of A is equal to half. Okay, so over here, I want to find, in order to find the y-coordinate of A, what can I do over here? I simply first can try to find, since A lies on the line AC, maybe what I can do is to find the equation of line AC. Okay, so over here, remember to find the equation of any straight line, I need two things, one point and gradient. So let's start by finding the midpoint of BD. Okay, because since AC is the perpendicular bisector of BD, the midpoint lies on line BD. So over here, midpoint of BD is simply equals to 1 plus 5 over 2, then 8 plus 0 over 2. Okay, I'll get 3, 4. Okay, so which means that this midpoint here is 3, 4. Then next step, find the gradient of BD. Okay, gradient of BD. Simply y2 minus y1, 8 minus 0 over 1 minus 5. Okay, I will get negative 2. So therefore, this tells us that since AC is perpendicular to BD, it means that, therefore, gradient of line AC is equal to the negative inverse, which is half. Okay, then from here, now I can now find the equation of line AC. Therefore, equation of line AC is simply y minus 4 over x minus 3 equals to half. Okay, then I can now find the equation of line AC. Y minus 4 equals to half x minus 3 over 2. Y equals to half x plus 4 minus away 3 over 2 plus 5 over 2. Okay, and since I know that at point A, since AE is perpendicular to the x-axis, which means that AE, they share the same x-coordinate, and the coordinate of point E is negative 4. So what I need to do is simply sub in x equals to negative 4. When x equals to negative 4, y will be simply half times negative 4 plus 5 over 2. Okay, which will give me half. Okay, so therefore, the y-coordinate of A is half, shown. Okay, this is for part 1. Okay. Next part. Find the coordinates of point C. We look at point C over here. Point C lies at this point here. And point C is the intersection between line AC and line BC. I know that I have found the equation of line AC in part 1. I am given the equation of line BC as well. So simply, the point C is the intersection between line AC and BC. I can simply solve simultaneous equation. Okay. Okay, equation of line BC is given as 3y plus x equals to 25. I can rewrite this equation. 3y equals to 25 minus x. Y equals to 25 minus x over 3. Okay. Therefore, I have found the equation of line AC as well over here. Okay, so therefore, sub, or I can say equate equation of line BC to equation of line AC. Okay, so therefore line BC is simply 25 minus x over 3. I can rewrite this to become 25 over 3 minus x over 3. And line AC is given by half x plus 5 over 2. Okay, so therefore if I rewrite this, I'll get 1/3 x plus half. I'll get 5 over 6x equals to 25 over 3 minus away 5 over 2, 35 over 6. Okay, therefore very simply you can solve from here. X equals to 35 divided by 5, which is equal to 7. Okay, therefore I found the x coordinate, so sub x equal to 7 into any equation. Let's say equation of line BC, for example. Okay, y coordinate is simply 25 minus 7 over 3. I'll get y equals to 6. So therefore C is simply 7, 6. Okay, and this is the answer to part 2. Okay, and for the last part, find the area of quadrilateral ABCD. So area is simply, you can take the shoelace method. I found the coordinates of A, B, C, and D. I can now use my shoelace method. Okay, so over here, area is simply equals to half. Okay, I start with, let's say, point B. Okay, then I go anti-clockwise in this direction. Okay, so over here, I know that, let's write the coordinates to be clear. For A, I know that A is negative 4, half, and point C is 7, 6. Okay, so to use the shoelace method, I go in anti-clockwise direction. I start from 1, 8, so this will be 1, 8, negative 4, and 0.5, half, 5, 0, 7, 6, and I go back to the starting point 1, 8. Okay, and therefore to use the shoelace method is simply half times, I simply apply the shoelace method. Okay, I'll get 0.5 plus 30 plus 7 times 8, which is 56. Okay, this whole thing here minus away. Now I'll go the other direction. Here 2, 3, 4 minus away, negative 32 plus 2.5 plus 6. Okay, then let's simplify this from here. Your final answer in this question should be equals to 55 units square. Okay, remember to write your units because this is area. Okay, and with that we have come to the end of this paper.